Hi, I wanted to talk to you about the structure of matter, and hopefully, this will help you clear up some of the vocabulary that you need to know to study the geologic history of the Earth. Now, matter is anything that takes up space and has mass. So, a good way to think of that is, if you can weigh it, it has mass, and it's made of matter. So, the smallest unit of matter is an atom. So atoms are really tiny, and if you really get into it, atoms get even small. They're made up of smaller things, but an atom is this tiny little thing that can be, a hydrogen atom, or sometimes you have an oxygen atom, or you have a carbon atom, and everything that is made of matter is made of atoms. Now, because there's different types of atoms, when we get into that, we're actually talking about elements. So if we, let's say, have a whole bunch of hydrogen atoms together, if something's made of the element hydrogen, and the periodic table of elements has all the different known atoms, or the different types of atoms that we know of. The next term is a molecule, and a molecule is when you get more than one atom bonded together. So examples of molecules out in the just floating around in the air, the oxygen you breathe isn't actually individual oxygen atoms. They're bonded together, so sometimes you'll see O2. Another thing in the air is CO2, or carbon dioxide, and what comes out of the tap in your house is water, or H2O. So when you have two hydrogen atoms bonded to one oxygen atom, you have a single water molecule. So here's your oxygen, and then you have a hydrogen atom bonded to it, and another hydrogen atom bonded to it. Realize this is still way too small to see, but when you get millions and billions of water molecules pouring out of your faucet, you can see it. Then there's compounds. So a compound is very similar to a molecule. The only difference is you need to have more than one type of element or more than one type of atom making up the compound. So if we take a look at these three above, oxygen, or O2, is not a compound because it's made of the same kind of element or same kind of atom. However, CO2 is a compound, H2O is a compound. Anytime you have different atoms bonded together, you have a compound. Then the next thing we're going to look at is a mineral. And a mineral, it's different than a rock in that a mineral always has a set chemical formula. So one mineral that is very common is quartz. And quartz has the chemical formula of SiO2, meaning that to get quartz, you have to have one silicon atom bonded to two oxygen atoms, and that would make one molecule of quartz. And then obviously, quartz is a common mineral in a lot of rocks. And in California, if you have this piece of granite, like in Yosemite National Park, it's made of quartz, mica, and feldspar, three different minerals. The big difference between a rock and a mineral is with the mineral, the quartz is put together with a certain proportion of atoms. However, you can have different amounts of quartz, feldspar, or mica in granite, and that's why not all granite looks the same. And often a lot of igneous rocks are mislabeled granite when they're actually something else. So to end with, let's take a look. This is at the small end. This is at the big end. And these things are on this spectrum. Realize everything down here is made of atoms. But when you get down here, you have just one unit of matter. Elements, that term is used to describe the different types of units, the different types of atoms. When you get a molecule, you have more than one atom bonded together. The only difference between a molecule and a compound is a compound has to have more than one type of element. So remember, O2 is not a compound, but CO2 is. Then when you get to a mineral, our example was quartz. All minerals have a chemical equation, or a chemical formula, so you know the proportions put together, and then rocks are made of minerals. Here's the big end, there's the small end.